Uh, in the previous session, we have seen how to calculate velocity of different mechanisms using relative velocity method, and here in this session, we will apply that relative velocity method to different examples. Uh, and first, we consider this example. It's asked in 2014, and if you can recollect, this we have already solved in the previous session using the instantaneous center method. And here we will apply this relative velocity method, and we will see whether we get the same answer or not. And here in the relative velocity method, there are three steps we already mentioned. The first step is you identify the fixed point, and the next step is first draw the velocity vectors, known velocity vectors which are known, and after that third step remaining you draw remaining velocity vectors whose directions are known to us, so that the polygon or a triangle or whatever polygon will be completed, or it will become closed. So here first identify the fixed points. Here in this one there is no fixed point, but they have given velocity of the point P and Q on this link. So this is absolute velocity and this is also absolute velocity. That means it has to be with reference to some other point. So that point I will consider as a O, and they have given velocity of the Vp in this direction. So let's draw velocity of Vp like this, and the velocity of Vq which is making angle 45 degrees with the link, horizontal. So here I have drawn a velocity Vq. So this is a known vector. So this ends here, and its magnitude is known to us. So let's say this is a Q and this is known to us, and this is a velocity vector Vp and its magnitude is not known. So that's why I have randomly drawn some horizontal line. And here we need to draw, according to third point, we need to draw other velocity, that is a velocity, relative velocity of the Q with respect to P. So but here in this case this is moving in this direction and this is moving in this direction. So this velocity, relative velocity of the points Q and P should be perpendicular to this link PQ. It can be like this or it can be like this, because we don't know in this particular instance whether it's rotating like this or it's rotating like this. So it can be like this or so we will start a point from the end of the Q or VQ velocity line and draw a line parallel to this velocity vector VQP. So if I extend like this, so this is a touching here. So this is the point P. So this is our point P, and this is the required velocity of the point P, and this is the velocity of the Q or P with respect to P. This is the velocity triangle, and generally in the semester exams we carry scales and drafters so that we can easily measure these values from this one, because this velocity triangle generally drawn to a scale. So scale means, for example, in this case this velocity Vq is given as a 1 meter per second, but what if velocity Vq instead is given 100 meter per second, then we cannot draw 100 meters as equivalent to the 100 centimeters. So we will reduce this 100 centimeter using a scale by either by dividing by 10 or 20 or 5. So according to that scale we will draw all these values, and at the end when we find out the Vp, again we need to multiply whatever the scale that we diminished or reduced. Here always no need be reduce the scale. So for example, if Vq is 0.01 meter per second, then in that case, so we should increase the scale. So it should depend on the what is the value that they mentioned in the problem. So that's how we carry out and solve in case of semester exams. But here in the gate exam, we don't have that much of time, or either we may not get the required accuracy. So and we may not be able to carry drafters or scales. Cut. start. So in that case, how to solve this one? So here this VQ, velocity vector VQ is making an angle 45 degrees with the horizontal. So I identify this as a 45 degrees, and we need to find out this angle and this angle. So how to find out first this angle? So this angle means nothing but this is a making how much angle is a making with the horizontal. For example, this is a perpendicular to this link. This is perpendicular to the link, but link is already making an angle 20 here. So if the link is horizontal, then this velocity vector QP could have made or could have been like this at this direction, but because of this 20 degrees rotation, this is also oriented 20 degrees. So how much angle is making at this position? That is a 70, because if it had along this line, then it's a 90 degrees, but it's oriented 20 degrees here. That means it's a consumed 20 degrees in the 90 degrees, so it's making 70 degrees here. So it's making, if it is making 70 degrees here, automatically at the horizontal, lower horizontal, it's making again 70 degrees. Because this is making 70 degrees, that means here the angle is 70 degrees. So this is 45 and this is 70, then this angle is 65 degrees. And here again we can apply the sine formula. So sine formula equal to VQ, and what is the angle opposite to VQ? That is a sine 70 degrees equal to VP by sine 45 degrees equal to VQP by sine VP. This is a VP and opposite angle is 65, not 45, and VQP opposite angle is this one 45. So this is a 45 degrees, and we need to find out VP for a given VQ. So what is the VP? VP equal to VQ. VQL is 1 into sine 65 degrees by sine 70 degrees, then we will get 0.96. So last in 2005 we have already seen we have already solved this question using the instantaneous center method, and I'm skipping the first bit because we have already seen this is a rocker mechanism, and we need to find out what we need to find out in the second bit, magnitude of angular velocity of the O4B. So for example, if I mark this one as a link 1, 2 and 3, 4, so we need to find out angular velocity omega 4, because here omega 2 is given. So omega 2 is given as a 8 radian per second, and we need to find out this one. So let's start this. So first step, what is our first step? So first identify the fixed points. So those two fixed points are O2 comma O4, and what is our next step? So identify the known velocity vector. Here only velocity of A is known, because omega 2 is given, angular velocity of the link 2 is given. So what is the velocity of A? Velocity of A equal to omega 2 into O2 A. So that equal to 8 into 60, and at this position this link is perpendicular to the horizontal, and the velocity vector is like this. Velocity vector is like this, VA. So we will draw the velocity vector, which is a known value. This is a known value. So this is the VA, velocity of the point here, and if I consider velocity of the B, here in this instant, this link 4 also rotating in the anti-clockwise direction or counter-clockwise direction, and link 4 also here fortunately perpendicular to the horizontal, so that velocity of the point B here in this case is again parallel to the horizontal. So like this. So velocity of the B also along the velocity of the B also, I will draw velocity of the B with a red mark. So velocity of the B also along the VA, but we don't know where to stop this one. So let's say it's going up to this position, and now I will take this link AB. So here I want to draw velocity of the, here I want to draw velocity of the B with respect to point A. So that is the relative velocity of these 2 points. So again this relative velocity always perpendicular to the link joining point A and B. So it should be something like this, perpendicular to this one. This is the velocity of B with respect to A, and this is the velocity of B. So how to start this one? So I know end point of the velocity vector A, and from that one you draw a perpendicular, draw a line which is perpendicular to the link AB, or draw a line parallel to the velocity vector VBA, so that it touches the velocity vector VB. This is the VB. But here these two are coincident, so that this at this point itself these two are intersecting. That means here in this case velocity B equal to velocity A, because this point is touching at the same position. These 2 points are touching at this point. So here velocity of the VA equal to velocity of the VB. So what is the velocity of the VA? This is the velocity of VB. So that the velocity of point B equal to again 8 into 60 mm per second. But here what is asked? Here asked what is asked? Angular velocity omega 4. So but this can be written as omega 4 into link length 160. So that omega 4 equal to 80 into 60 by 160, and its value is 3 radian per second. And here one interesting observation is, so whenever some 4-bar mechanism or any mechanism is given, and if these two links you link 2 and link 4 is in this particular if these two links are like this as shown as in the present configuration, that means if these two are parallel to each other, then velocity of the at the end of the link 2, that means at the point A, is equal to the velocity at the end of the link 4, that is at the point B. So we can directly consider this relation, and we can save some time. So we immediately consider this problem. This is asked again in 2011, and if you observe in this problem also the 4-bar link mechanism configuration is as like to the or similar to the previous problem. Here link, for example, this is 1 and 2, 3 and 4. Link 2 and link 4 are again parallel to each other and perpendicular to the horizontal here. So if this is the case, then we can directly deduce that. If this is the case, then we can directly deduce or we can directly write like velocity of the point B equal to velocity of the point to C, because in the previous session we have seen even if you draw velocity triangles, we finally end up with this conclusion. And let's read the problem. Angular velocity of AB is given, so that means omega 2 is given, and angular velocity of the link CD is asking angular velocity of the link CD. So what is the omega 4? So again we know VB equal to VC, but what is the VC? That is omega 4 into CD. But what is the VC? Again that's a VB. So VB equal to omega 2 into AB. But omega 2 equal to 1 radian per second into Um, Here, what is the length of the AB? So, AB, length of the AB equal to 1.5 times into 1.5 times of CD. So, from these two, by equating these two, we can get omega 4 equal to CD will get cancelled. So, omega 4 equal to 1.5, that is 3.2 radian per second. So here, whenever you get a configuration like this, link 2 and 4 are parallel to each other, then blindly you can assume that velocity of the point B equal to velocity of the point C. Why I am saying no need to perpendicular to horizontal? For example, if the configuration is like this, if the configuration is like this, even in that case also, even in this case also, velocity of the B equal to the velocity of the C, uh, provided this AB parallel to the CD. Why? Because whenever these two are parallel, velocity of the B and velocity of the C on the same line, and whenever you try to find the relative velocity of the points B and C, again it touches the two vectors at the same point. So that means it gives same velocity for the point B and point C, making an angle 60 degrees with the horizontal here, and the velocity of a point A on the rod is 1 meter per second. This is in the downward direction. So we need to find out the angular velocity of the rod at this instant. So when, for example, this is the velocity of the point A, and I consider another point at this point here, let's say this is a point B, and if this is moving in the downward direction, then definitely this is moving in this direction, horizontal direction, into the right side. So and this velocity of A and velocity of B, if I consider velocity of A and B are absolute, then it should be, or it has to be with reference to a point. So our first step is identify a fixed point. So here in this case our fixed point is 0, and after that draw, after identifying fixed point, after that draw noun velocity vector. Here noun velocity vector is a velocity of A, and that is going in the downward direction. So this is a noun velocity vector VA, and this point is A, and after that unknown velocity vector, but its direction is known. So again velocity of the B in this direction we don't know its magnitude, so that's why I will draw a very bigger one, so VB. And now what is the velocity here? We need to draw relative velocity between the point A and B. So this is the velocity of the link. So this is a B comma A, and this should be perpendicular to the link, and it's starting from the A and ending to B. So you start at this point, because this is a known one, and draw a line parallel to the link, so that parallel to the velocity vector VBA, so that it touches here again. So this can be identified as a point B. So here we need to find out velocity of the B with respect to A, and this is a point O, and this is the velocity of the point B. And again if you, whether you can, either you can calculate this velocity VBA by simply measuring with a scale or a drafter, but here it's not possible. So again we will use some geometry or some trigonometry. So here this is going downward, and this is going upward. This is horizontal, and we need to find out an angle. This is a 90 degrees, and we need to find out an angle here. This is a perpendicular to this link. That means this is a 90 degrees and this is 60 degrees. So that it is making 30 degrees here. So if I draw some line here, it is making 30 degrees here. That means here it is making 60 degrees, and here this is a 30 degrees. So again sine formula, so VBA by sine opposite of this side, that is 90 degrees. 90 degrees equal to VA, because VA is the known value. VA by opposite of, what is the opposite of VA? That is a 30 degrees. So sine 30 degrees. So from this one we can calculate VBA equal to VA. What is the value of VA? That is 1, and sine 30 is 1 by 2. So it becomes 2 meter per second. But here we need to find out angular velocity of the rod. So omega AB. So this can be written as omega AB into length of the AB, and the length of the AB is 1 meter. So what is the omega AB then? Omega AB equal to 2 radian per second.